Hello and welcome to this video about finding the area of quadrilaterals part 2. The learning target for this lesson is finding the area of trapezoids. So we've gone over several different shapes, but now let's talk about the trapezoid because it has the most complicated formula. Now a trapezoid, typically when we draw them, we kind of draw them looking like this right here. And a couple of some of the terminology we have here, we call this one base 1, and this one base 2. It doesn't matter which one you call base 1, base 2, and it wouldn't matter if it's flipped upside down, so if it looks more like this, again, if we were to call this one base 2, this one base 1, it doesn't matter. So what we're getting at, though, is it's one of the parallel sides. The other thing we need to know is the height, and so that would be right here, and then right here. Now the formula, it's a little complicated, so bear with me. The area of a trapezoid, so we'll go trap, so that we don't confuse it with triangle, is equal to 1/2 parentheses b1 plus b2 times your height. Now, why is it this? Well, let me try to show you. So first of all, let's kind of get rid of all of that, and let's go back to a previous shape. Let's make a parallelogram. Now, in a parallelogram, we know that the area of this is equal to length times height. Again, where that's your height. Actually, let's erase that. We don't want that. All right, so length times height. Now, here's what we're going to do. I'm going to take my parallelogram, and I'm going to draw a line through it like that. Okay? Now, it might seem a little bit weird, but now let's take a look at the shape that I have made, outlined in red. That right there is a trapezoid. And here's the thing. Properties of parallelograms is that this side is the same length as this side. And so what I've done is I've cut it into two pieces. Now I'm going to get a little abstract here, but I'm going to call one of them B1 and B2. And the thing is, if I were to add these up, it's got to equal the original length of my parallelogram. Now here's the thing, if I've cut it up like that, it's also going to be the same up here. So, so like this part right here is going to be B2, this part's going to be B1. And I have another trapezoid just like this. And if I could, I would show you that these are actually the same trapezoid, and it just needs to be rotated, and it would fit perfectly on top of this guy. And the thing is, they both share the exact same height. So this is H, this is H. So we have our so essentially, we have the area of your parallelogram, but we have to cut that in half. And if we were to try to maybe find the area of this with just trapezoids, we take these, add them together, times them by your height, but we only have one of those, so that's why we end up dividing it by 2. So again, if we were to try to find the area of the big shape right here, we would go B1 plus B2 in parentheses, so we do that first, times by the height. But we only have one of these, so we divide by 2, or maybe move this 2 to the outside, write it as 1/2 B1 plus B2, and we have the area formula for a trapezoid. So let's practice it. Do some examples. So examples. Number 1, we're going to find the area. Again, you have to be given a lot of the information here. So let's say that this is 12. Let's say that this is 8. And you are told that the height here is 6. So it's all about plugging and chugging into the formula. So what we'll do is go area is equal to 1/2 B1 plus B2 times height. So plugging it all in, 1/2. We have 8 plus 12. The order doesn't matter in which you do that, times by 6. What does matter is making sure that we do this first. So we have 1/2, 8 plus 12 is 20, times by 6. I like to multiply my numbers first, so that would give me 1/2 times 120 before I bring in the fraction, which is equal to 60 units squared. Now, this works out really well if our numbers are all even. Occasionally, we're going to get some odd numbers, and we just have to deal with it. So, let's do an example with some odd numbers here. So let's go with another one. Let's also make our look a little bit different, so we get a different look for it here. All right, and let's say these are right angles. And so I'm told that this is 5. I'm told that this is 6. And I'm told that this one is 9. So I'm going to apply my formula. And all we have to do is be able to look at it and get like what's going on here. If I were to rotate this guy on its side just a little bit, it would look roughly like that, where 5 represents my height. And then this is one of the bases, this is the other one of the bases, and so that would be here and then there. So go into the formula, 1/2 parentheses B1 plus B2 times H. I end up getting 1/2 times 50, oops, I jumped the gun there, 6 plus 9, which is going to be 15, times 5. Now to deal with the numbers, we have 1/2 times 15 times 5. We could try to times by half here. We could hope that maybe if we would multiply these guys out, we'd get something even, but unfortunately we don't. So we're going to get 1/2, and then 15 times 5 is 75. And so we have a couple ways we can write this. We could write this as 75 over 2, or we could actually try crunching the numbers and seeing what we get here. So let's go 2, 75, 3, 6, that's 1, 5, so 7, and then we get 14, we'd get a 1, 0.5. So, or we could say 37.5 units squared. So that's trapezoids in a nutshell. It's a new look. It's a big formula, but it boils down to a lot of plugging and chugging. So just make sure you take care of your numbers. You show your work. I can't emphasize this part enough, where we kind of dwindle it down. Don't try to just go from here to there. That's going to be really hard to do. Take your time, show your work. Good luck on your homework or practice, and let me know if you have any questions.